Normally, a linked list ends with a link to nothing. But what if some node points back to an earlier node, forming a loop? Then a plain walk would go round and round forever. We need a way to detect such a cycle. Floyd's trick, again using a slow and a fast pointer, does it neatly. Imagine two runners on a track. If the track is a straight line with an end, the fast runner simply reaches the finish. But if the track is a loop, the fast runner keeps circling and eventually catches up to the slow one from behind. So we move slow one step and fast two steps. If fast ever reaches nothing, there is no loop. But if slow and fast ever point to the very same node, we have found a cycle. We start slow and fast ahead. While fast can take two steps, we move slow one and fast two. After each move, we check. If slow and fast are the same node, they have met inside a loop, so we return true. If fast runs off the end into nothing, there is no loop, and we return false. Let's test one straight list and one with a loop in a live editor. A node holds a value and a link to the next node. Both runners start ahead. Move slow by one, fast by two. If they meet, there is a loop. If fast reaches the end, there is none. Now let's test it and hit run. There it is. The straight list gives false, and the list whose tail points back gives true, because fast caught slow. Here's the shape. Both start ahead. While fast can move twice, step slow by one and fast by two, then check if they are the same node. If they meet, return true. If fast reaches nothing, return false. Even though fast moves twice as fast, it catches slow within about one lap of the loop, so the whole thing is order n time. We use only 2 pointers, so the extra space is order 1. This beats storing every visited node in a set, which would cost order n space. 3 things. First, compare the pointers with is asking whether they are the very same node, not whether their values match. Second, always guard fast and fast dot next before stepping fast twice. And third, you could instead remember every node in a set, but that costs order n extra space, while Floyd's trick costs almost nothing.